Good evening, AP Chem students. Here is the promised problem 1.71. Please bear with me. This is the first video I have ever made on this program. Alright, but I'm going to start off by reading the problem to you, and then I'm just going to talk to you about what I would do next and what I'm thinking as I go through the problem. Okay? So, to start with, it is 1.71. Here it goes. A 32.65 gram sample of a solid is placed in a flask. Toluene, in which the solid is insoluble, is added to the flask so that the total volume of the solid and liquid together is 50.00 milliliters. The solid and toluene together weigh 58.58 grams. The density of toluene at the temperature of the experiment is 0.864 grams per milliliter. What is the density of the solid? Okay, there's a couple of things that we need to wade through after you read a problem like this. We don't know what the solid is. It's not going to be an important detail, but they do tell you that it's added to toluene, which will be a solvent, and that it's insoluble. Basically what that means is that toluene, being a solvent, something they're placing this in, and it could dissolve, but it's not going to react and become a new compound. So they're going to stay with their same identities, and they're going to mix together, or at least they'll be together in a way that we can't separate them. Okay. One of the things that might help before you start thinking about where to start is to actually dissect this information and put it down in a format that shows you exactly what information you have. So if you can see on my screen here, I'm going to pull the screen down. I put this in a table. You don't necessarily have to make a table, but it sounded a lot like some lab work. So if I was going to take the mass of something, I would record it in a table. So this is just a quick, easy way for you to visually separate out the things you do know. You could also just list them as long as you label what they are so that you know which goes with what. So these 4 pieces of information are what I got from the problem. There's a mass of this solid that I don't know what it is. There's a total volume of the two things combined. There's a mass of the solid with the toluene. And then there's the density of just the toluene. And this is all the same experiment, so we're going to assume that the same conditions are present for both compounds. So that means that we don't have to make any adjustments, basically. Okay? So back to what it's actually asking us. At the end there, it says, what is the density of the solid? Okay? In order to find density, density is the mass divided by the volume. Okay, so you've seen this before. If we have the density, we don't, of the solid. We do have the density of toluene, but that's not what it's asking for. Okay, we need the density. Okay, in order to find that, we need the mass and the volume. We do have the mass of the solid. We have a combined volume, which if we can separate out the volumes by having maybe also the volume of just toluene, we could subtract that out and be on our merry way with this calculation. But it's not going to be that simple this time. We can't separate anything out because we don't have any other volumes to manipulate this with, so we can't use that. We can solve for volume if we have density and mass. We have the density of toluene. We could find the mass of toluene, so that's how we're going to get at least one of the volumes, and then we can come back to this volume and then separate them out once we have toluene's volume. Alright, so in order to do that, the first thing we need is the mass. We have a combined mass, but we do have the individual mass of the unknown solid, so we can go ahead and subtract those. I'm going to scroll down. So here is that combined volume. I have some text hiding here. Now if we subtract just that unknown solid's mass, we get this 25.93 grams. That's the mass of all of them. We'll keep that there. Okay. But then we need the volume. We need to rearrange this equation so that we can solve just for volume. Okay, so we did this in class today, but I'm going to do it again real quick here. So if we have density equals mass over volume, we need to move volume out of the bottom first because we can't do much with it existing as the opposite of volume, the way it is now. So the first thing we're going to do is multiply by volume, which is the opposite of 1 over volume. Okay. Then we're going to do that on the other side too to keep things fair. Once these cancel, okay, those will cancel. Here's what I have. I have volume times density equals mass. Well, I don't want mass by itself. I already have the mass, so I have one more step. I need to divide by the density to get rid of it on this side, and then I'll do that over here. And this leaves you with volume equal to mass over density. Okay, so in case you forgot, there it is again. Okay, now I know what order I need to put things in. I can plug and chug. Let's scroll down here. Here is the mass that I just subtracted from the combined mass and the unknown mass. So I'm just going to plug that in here. If I divide that by the density that I was given for toluene, that's what I'm given here. Okay, and that's going to give me, I'll give you a second to catch up in your calculator, but here you go. That's going to equal 30.0116 milliliters. If this was where we were stopping, we could make this 30.0 milliliters. In your book, they sometimes will do this rounding at each step. Please don't do that, okay? Keep this long value until you're all the way done. That'll make your life a little easier. You only have to round once. Okay. We can now separate out the volumes that we were talking about before. All we really need to do is subtract. So if you take the volume that we had, that total was 50.00 milliliters. Subtract this volume that we just calculated. Okay, you do that in your calculator to be very precise. And you get 19.9884. Alright, the next thing we need to do is actually solve for the density of this unknown solid like it asked us in the beginning. Okay, we can use the standard D equals M over V equation and just plug everything in. Okay, so here I've plugged it in for you already. It's the 32.65 grams that were given in the very beginning, dividing by the volume that we just calculated for the solid, 1.63 grams per milliliter. If you have any other homework problems that you'd like me to walk you through, please just email me, just ask me, tell me what problem to do, tell me what in particular is getting you stuck, and then maybe I can tailor this a little more specifically to you. Otherwise, have a great night, and we'll see you in the morning.